Hi, my name is Chia-Ching, a student from Computational Intelligence and Automation Lab at National Chia-Ching University. In this video, I would like to introduce a through-silicon via constraint Chia-Ching reordering tool named 3D-MFH.
Interconnect along with technology scaling plays an important role in deciding circuit performance. Structural three-dimensional integration is emerging as a promising solution to reduce the length of long interconnects across the circuit. So the motivation of 3D ICs can be concluded as to fit Moore's law, to mitigate interconnect-related problems, to enable heterogeneous integration through silicon via. The TSV-based 3D ICs is a possible method to implement 3D integration. TSVs provide the best performance of interconnect on timing and power among other vertical integration techniques. TSV is 6 times bigger than a standard cell. TSV influences the yield of a die greatly. RTI claims that the presence of a TSV will lower the yield rate from 100% to 99.98%. 100 TSVs will drop the yield rate to 98% and 1,000 TSVs will result in 82% yield rate. Considering the yield loss, the usage of TSV is typically limited during the designs of 3D ICs. When 3D ICs are being designed, designers should also consider the design for testability issues so the defects within the ICs could be detected more conveniently. We integrated the traditional 2D scan testing technique, Chia-Ching designed to 3D IC testing to overcome the design for testability issues. This is a structural representation of TSVs in the 5-layer 3D ICs. This is the flowchart of 3D-MFH. After reading 2 input files, which are a Verilog circuit and def-left files, the proposed algorithm is used to obtain an initial solution at first, and then do local optimization for the initial solution. Finally, a graphical layout and the Chia-Ching ordering files are generated. Previous works usually use genetic algorithm to solve the 3D scan reordering problem. However, it is very time-consuming. So, we propose an efficient algorithm to optimize scan stitching wire with or without TSV constraints. The algorithm composes of 2 stages. At stage 1, we use multiple fragment heuristic to quickly find a good initial solution. And at stage 2, 3D planarization and 3D relaxation are used to do local optimization and constraint solving. This is a comparison between the proposed algorithm and the genetic algorithm without TSV constraints. The first column contains 3 ISCAS benchmarks. The highlighted section compares the scan stitching wire length of the 2 algorithms. The improvement varies from 3 to 7%. This section compares the execution time of the 2 algorithms. The proposed algorithm has improved the runtime by 2 orders at least. After the initial solution found in stage 1, we then used 3D planarization to locally optimize an initial solution, where we achieved an additional improvement on scan stitching wire from 5% to 7%. When TSV's constraints are considered, most cases still had improvements from 0.3% to 4.4%. The improvement in runtime is still by 2 orders at least. When the 3D relaxation is used to constrain the number of TSVs, the number of TSVs will be limited by an arbitrary number specified by the user. However, 3D relaxation will degrade the length of scan stitching wire shown by 2A. Therefore, 3D planarization will be applied and the results are recorded in stage 2B. The improvement from stage 2A to stage 2B varies from 35% to 62%. This is a brief introduction to 3D-MFH. This is a 3D-MFH software that we have developed. First, we need to open a flip-flop location file and the ISCAS benchmark file. The left picture shows the scan cell arrangement. Different colors represent different layers. After initialize icon has been clicked, an optimized Chia-Ching ordering without TSV constraints will be generated. After optimized icon has been clicked, an optimized solution Chia-Ching ordering considering TSV constraints will be generated on the right. The left bottom corner and the right bottom corner illustrates the total wire cost and the number of TSV with respect to each solution. There are a few additional features, including first, show height routing. Second, show the structure of a certain layer. Third, show only the TSVs.
This is the conclusion of my presentation. Thank you for your time.